Hi everyone, today we are going to introduce phenol. So phenol consists of an aromatic ring which is being substituted by a hydroxy group, and it looks like this. And it is highly reactive than the alcohol due to the stability of the conjugate base. So this compound is the conjugate base, and why we say that it is more stable is because it can form multiple resonance structure due to the benzene ring and the electron donating group of this oxygen. So this resonance give the stability of the conjugate base, and this is why phenol is a highly acidity and more reactive than the alcohol. Now, and because phenol is more reactive than alcohol, therefore the condition required by the phenol is less stronger or milder than the aliphatic alcohol. So the first reaction of phenol is when it reacts with a diluted NaOH, sodium hydroxide. And basically acid-base reaction occurs, we'll get a phenoxide ion. So this is the conjugate acid and this is the conjugate base. Now the second reaction is esterification, which is a very important reaction in between the phenol and carboxylic acid derivatives. Notably, the phenol will not react with carboxylic acid because carboxylic acid is less reactive than acyl chloride and acid anhydride due to the resonance structure that can be formed in the carboxylic acid. And because of this oxygen or this hydroxy group is an electron donating group, that means the electron pair in this oxygen is going to be decreased, and therefore it cannot act as a good nucleophile to attack the carbonyl center of the carboxylic acid, and therefore the reaction between phenol and carboxylic acid will not happen. But instead, when we react it with, let's say, an acyl chloride, concentrated H2SO4, which act as a dehydrating agent, and what will happen is this phenol will act as a nucleophile and attack the acyl chloride and give us the ester. And the third reaction of the phenol is being substituted by electrophiles, and so therefore it is actually an electrophilic substitution reaction. But because it is highly reactive and the electron density will delocalize into these three positions, which is ortho and para, therefore we don't need any condition. We just put Br molecule, and what we'll get is a tri-substituted phenol. Well, the phenol, it can also react with HNO3, and if this HNO3 nitric acid is concentrated, we will also get tri-substituted phenol. What if we want to get a para or ortho substituted phenol? Then we need to add a co-diluted HNO3, and probably we'll get a para or ortho. And that's the overview of the reaction of the phenol. And two things you have to remember in short: phenol, due to its high acidity and reactivity than the aliphatic alcohol, and this is due to the electron donating group of the oxygen as well as the stability of the conjugate base due to the resonance structure that can be formed.